So we have matrices, which is a way of representing a relation using 0, 1 matrix, right? So how does that look like? It looks something like this. This is a matrix. So to start off, we have to draw a matrix. And how do we know the size of the matrix? The size of your matrix is determined by the cardinality of your set A and the cardinality of your set B. So what's your cardinality of set A? We have 1, 2, 3. That's 3, and 1, 2, 3, 4. That's 4. So our size would be 3 by 4, which we can draw something like this: 0, 1, 2, and 1, 2, 3, 4. And then we draw our matrix, which looks like this, like a box, right? And now we look at our relation. Okay, we look at our relation and then try to see if it is 1 or 0, right? 1 means true and 0 means false. So first we have 0, 1 in our relation. Do we 0, 1? Yes, so this is true. We write down 1. And then what about 0, 2? Do we have 0, 2 here? No, we don't. So we write down 0. And then do we have 0, 3? Yes, we have 0, 3 in our relation, so we write down 1. Do we have 0, 4? We do not have 0, 4, so we write down 0. And then so on and so forth. You keep going. We have 1, 1. We have 1, 2. Right, 1. Wait, no. 1, 1. 1, 2, yes. And then 1, 3. We don't have 1, 3. 1, 4. We have 1, 4. 2, 1, we do not have 2, 1. 2, 2, we have 2, 2. 2, 3, we do not have 2, 3. 2, 4, we do not have 2, 4. So this is basically it. This is your matrix. This is your matrix based on your relation R. And yeah, that's it. That's the introduction to matrices. Yay. Okay, so next we have matrix transposition. It is very simple. You basically just switch the columns and rows of your M. So we'll take this matrix as our example. So we just switch the columns, right? So let's draw our matrix. Yep, there it is. And then yeah, this one. So we know it's 1, 0, 1, 0, right? So we do it like 1, 0, 1, 0. And then 1, 1, 0, 1 is 1, 1, 0, 1. And then 0, 1, 0, 0. 0, 1, 0, 0. That's it. Very, very simple. You just switch the rows and columns. I shouldn't have made this very big. Let me just do that. That's it. Matrix transposition. Okay. So we already know what a matrix looks like. We already know matrix transposition, stuff like that. Next, we will move on to reflexive. Okay. Note that reflexive is always a square matrix. Okay, it cannot be a rectangle. That means it has to be a 3 by 3 or a 4 by 4, 5 by 5, stuff like that. And if the center main diagonal is all 1, right, that makes it reflexive. Irreflexive, however, is when the center main diagonal is all 0, right? It's all 0. It doesn't matter if you have like a 1 here or 0 here or 1, 0, whatever you write here. As long as the center diagonal is all 0, that makes it irreflexive. That's it. We move on to more kinds of matrices. Oh god. We'll take this slowly. First, we have symmetry. Symmetry is when every value is equal to its transposed position, right? So here's an example. We have relation 1, 1, 1, 3, 1, 4, 2, 5, 3, 1, 4, 1, 4, 4, 5, 2, and 5, 5. So let's do it one by one first. 1, 1. Do we have 1, 1 here? Yes, we do. My notebook is... Next, do we have 1, 2? No, we do not. What about 1, 3? Yes, we do. And we have 5, 5. Yes, we do. Okay, this is our matrix, right? Okay, very good. Now, do you remember MT or the transposition of your matrix? You basically just switch the columns and rows of M. So let's do that. Woohoo! Okay, look, we now have our transpose matrix. Notice that even if I switch all the values, it is still the same. Look, see? 1 is here, 1 is here, 0 is here, 0 is here, 1 is here, 1 is here, 1 is here, 1 is here, 0 is here, 0 is here. And same goes for our columns, right? Our columns and rows are just the same as our matrix. So that's how you check if your symmetry or if your matrix is oh my god, I'm having a stroke. That's how you check if your matrix is symmetric, right? Or if you don't want to write down your transposition, you can just look at it like a mirror. It's like a mirror, right? Looking into a mirror. This is your mirror, this line I drew, and then look at this line. We have 0 here, we have 0 here. We have 1 here, we have 1 here. We have 0 here, we have 0 here, we have 1 here, we have 1 here. We have 0, 0, 0, 0, 0, and then 1, 0, 0, 1. 0, 1, 0, 0, 0, 1. It's like looking into a mirror. Well, whatever is here, it is copy pasted here. Bam! That's how you know if it's symmetric. Asymmetric, on the other hand, is it must be irreflexive. Do you remember irreflexive? Irreflexive is when your diagonal is all 0. Okay? So it must be irreflexive. Okay, that's all 0. Let's check. Next, every value is not equal to its transpose position. So it's the opposite of your mirror, right? If this is 0, this should be 1. If this is 0, this should be 1. Let's pretend this is 0. If this one is 0, this should be 1. So on and so forth. So like, it's the opposite of symmetry, but all of your diagonal should be all 0, right? What about anti-symmetry? Anti-symmetry, it's just like asymmetry, but your center diagonal can have both 1s and 0s. So it doesn't have to be irreflexive, right? So same thing, if this is 1, this should be 0. If this is 1, this should be 0, so on and so forth. While your diagonal can be 1s or 0s, right? It doesn't have to be all 0. It can be 1, it can all be 1, it can be a mix of 0 and 1, so on and so forth. So yeah. Okay, so we're now at the transitive. It's a little difficult, but remember that if A is related to B and B is related to C, then A is related to C. It's difficult to show it through matrices, but it's possible. So here we go. We have our example relation R, 1, 1, 1, 2, 2, 1, 2, 2, 1, 3, 3, 2, 3, 1, 3, 3. Okay, so we'll start doing it. 1, do we have 1, 1? Yes, we do. We have 1, 1. Remember that if A is related to B and B is related to C, therefore A is related to C. If 1 is related to and 2 related to 1, therefore we should have 1, 1. Do we have 1, 1? Yes, we do. Right? Next, if 2 is related to 1 and 1 is related to 2, then 2 is related to 2. Do we have 2, 2? Yes, we do. What else is related here? If 2 is related to 1 and 1 is related to 3, we should have 2, 3. Do we have 2, 3 here? Oh fuck, we're supposed to have 2, 3. Hold on guys. If 2 is related to 1 and 1 is related to 3, we should have 2, 3. Do we have 2, 3 here? Yes, we do. That I definitely didn't add that one just now. So yeah, let's see, it's true. If 1 is related to 3 and 3 is related to 2, we should have 1, 2. Do we have 1, 2? Yes, we do. And 3 related to 2 and 2 is related to 1, we should have 3, 1. So 3, 1 right here. Is there anything else? If 3 is related to 2 and 2 is related to 2, therefore we should have 3, 2. Do we have 3, 2 here? Yes, this is the one. And yeah, so on and so forth until we get this one. Ta-da! Okay, so I have another example for transitive. now we have relation 1, 1, 1, 2, 2, 3, 1, 3, 4, 5, 5, 3, and 4, 3. So we'll do the same thing. 1, 1, 1 related to 1, it's related to itself. Next is, if 1 is related to 2, and 2 is related to 3, we should have 1, 3. Do we have 1, 3? Yes, we do. Look at this. 1, 2, is the 1, and 2, 3. Where's the 2, 3? This is the 1, okay? Let me circle this first. We have 1, 2. Wait, no. We have 1, 2, and we have 2, 3. Therefore, we should have 1, 3. 1, 3. Okay, that's a transitive, right? Like that. Next is 4, 5. Okay, we have 4, 5. 4, 5 is the 1. And we have 5, 3. We have 5, 3. We have 5. If 4 is related to 5, 5 is related to 3, we should have 4, 3. 4, 3. 4, 3. This is the 1. So notice the pattern of your transitive. This is the pattern of transitive. If you notice, we have like 2 circles and then they all cross and they give 1, right? They make this true. That's the transitive. The same with this one. If we are given like 5, 3 and this is 4, 5, and then we cross that together, this becomes true. 4, 3. Yeah, that's like the pattern of transitive. Again, it's difficult to show it through matrices, but if sir shows something like this, it should be much easier to point it out, right? And for this one, remember, it's just a reflexive element. One is related to itself, so you know this can be disregarded. But yeah, this is an example of transitive, right? Okay, so remember bit operators? We have the or and and. Remember this, like the 1, 1, 1, 0, 0, stuff like that? Yeah, think of it as that, but you're putting all of them in a box. You're putting them in a matrix. So we have 2 things here. We have join and meet. Join is the or, and meet is the end, okay? So let's have a recap. What is or? Okay, or is like, if this is your x and this is your y, your bit up will be 1, right? Or if this is your x and this is your y, your bit is 1. If this is your x and this is your, oh shit, and this is your y, your bit is 1. If both of them are 0, it's 0. And on the other hand, it's like, if this is your x and this is your y, it's 0. This is your x and this is your y, this is 0. If they're both 0, it's still 0. If they're both 1, that's the only time it becomes 1, or true, basically, right? Think of it as a and is basically both of them have to be true, and or is like only one of them needs to be true. So let's do it here, okay? Let's do it here. We have matrix R and matrix S. We want to find the or the join of matrix R union S, right? So we look at this. 1, 1, so we write 1, okay? 0, 0, we write 0, okay? And 1, 1, we write 1. And in this one, we have 1, 0, because we have at least one value, we write 1. And then same with this, 0, 1, we have 1, so we just write 1. And 1, 0, we just write 1. And then same with this, 0, 1, we write 1. And then 0, 1, we write 1. And both of these are 0, so we write down 0. That is your matrix R union S, right? Next, we will do meet. Meet is the end of it, right? If you remember end. So we want to find the matrix R intersection S, if that's how you read it. So basically, both of it has to be 1. So if this is 1 and this is 1, we write on 1. This is 0, and this is 0, we write down 0. This is 1, this is 1, we write down 1. And this is 1, but this is 0, we write down 0. Right? And then this is 0, this is 1, we write down 0. And then 0, 1, we write down 0. And then 0, 1, write down 0. 1, 0, we write down 0. And 0, 0, we write down 0. So yeah, here's the, this is how you answer. This is how you get joined in. Very, very simple.
This is supposed to be easy, but it's kind of hard to teach because of the lack of space I have. So fuck you, I have an entire whiteboard for myself.
So what's our goal here? Our goal here is that we want to find MS of R, or the matrix S of R. How does that work? Basically, we're given two matrices. We have matrix R and matrix S. We're going to use this to find the answer, which is this, okay? I'll teach you how to do that. And that is through this. We have 3 steps. Step 1, we take the row. Let's move on here. Fuck. Red marker. Move on. Take the row of MS. Okay? This is our MS. So we take the row. This is the row. Row number 1. 101. Right? And then we put it here. We align it as so. Right? What's the next step? The next step is to find the end value. So if you remember what end is, it's like truth value, right? 1 and 1. If both of them are 1, then it returns 1. What about this? 1 and 0? Oh, not both of them are 1, so it returns 0. 1 and 1, it returns 1. And then we do the same here. Now we move on to the next row. So 0. 0 and 0, that would be 0. 0 and 1, that would be 0. 0 and 1, that would be 0. Automatically, here's a tip. Automatically, if you see this is 0, everything is going to be 0, right? Next, 1. 1 and 1, that would be 1. 1 and 1, that would be 1. 1 and 0, that would be 0. Okay? Next, we go back to step 1. We take the row. Now we move on to the second row, right? So we erase this, and then we bring this 0, 1, 0 right over here, 0, 1, 0. And then we do second step again. We find the end value. So we do the same shit. Look, 0. We already know that this is 0, so automatically all of these are 0. This one is 1, so 0, 1, 1. Okay, 0, 1 and 0, that would be 0. 1 and 1, that would be 1. 1 and 1, that would be 1. Next is 0. Yep, that's all zeros. And now we move on to the next row. Keep doing this until you finish all the rows. Okay? So in the last row, we have 0, 0, 0. I think it's very simple where this is going. So this is 0, it's already all 0. And same with this, all 0. And this one, all 0. Alright, we have them all. We're almost done, guys. We are almost done. Now we move on to the next step. We find the OR value. Okay? We can finally not look at this. Don't look at this. This is Cancer. Now we just focus on this one. We find the OR value of these guys, of this group. Per group, we find the OR value. So, if you remember what OR value is, only one thing has to be true, and then it will return true. Or like this. Or if both of them are true, then it's, oh wait, fuck, I didn't mean to do that. If both of them are true, then it's still true. The only time it will be false is if both of them are false, right? So let me erase that. Okay. So we take a look at this. We have, in this group, how many true values do we have here? We have 2 true values. So, wait, hold on. I have to draw this here. My bad. Okay, again. So we apply the OR function here. Function OR value here. So we have 2 true values. We have 2 ones, right? So automatically, that would be 1. Next, how many true values do we have here? We have none. All of them are zeros. therefore it's 0. How about here? How many true values do we have here? We have 2 true values, therefore we return 1. Here we have no true values, it's all 0, so it's 0. This one, we have 2 true values, so that is 1. And then this one is all 0. And we already know that all of these are 0, so we replace 0, 0, 0. Okay? Okay? Also, just in case you guys are wondering, what if this one is 0, right? What if this one is 0? Like, what if there's only one true value? Well, it doesn't matter. It's still going to be 1, right? It will still return 1 because it only needs one true value, okay, for OR to return 1. But anyways, let me just put this back. And this one, what we see here, boys and girls, is our MS of R. This is our MS of R. And that's how you find the answer. Again, recap. Take the row, find the end, and find the OR. And there we have it. It's a little long, but once you get used to it, you can just glance at this and you'll find the answer. It's very, very simple. You guys got this. I hate you!